Alright, so we're going to start off today with this warm up. What are the x and y intercepts of the line y equals 3x plus 0? So in order to solve for these x and y intercepts, we have to think, what is an intercept? So, an intercept, we look at a graph. Say our line looks something like this. An intercept occurs whenever our line is touching one of those axes. So we have an x-intercept when we cross the x-axis, and we have a y-intercept when we cross the y-axis. So those are the points that we're looking for. Now, if we look at my x-intercept, my y value, anywhere on that x-axis, is always 0. At my y-intercept, my x value is always 0. So, depending on which intercept we have, the other coordinate will always be 0. So, if we notice, both of those intercepts occur when the other value is 0. So my y-intercept occurs when my x value is 0. My x-intercept occurs when my y value is 0. So we can use this information to help us solve for our intercepts. So if I want to solve for my x-intercept from my equation, I'm going to have to plug 0 in for my y in order to solve for my x-intercept. So I would have to solve for x to figure out what that coordinate is of that x value. Let's see. Subtract 6, I need to inverse my constant first. That gives me negative 6 equals 3x. Divide by 3, and I get x equaling negative 2. So, my x-intercept occurs when x equals negative 2. But I need to think that it's a point, it's a coordinate point. So the actual coordinate would be x equaling negative 2 and y be 0. Whatever. When you solve for 1, your other value is going to be 0. So we can do this exact same thing to solve for my x-coordinate, or my y-intercept. So my y-intercept occurs when my x value is 0. So I'm going to plug 0 in for my x to solve this. So 3 times 0, that's going to be 0 plus 6. So y equals 6. So my y-intercept is occurring when y equals 6 and when x equals 0. So this wasn't too hard to be able to solve for that, especially because we were in slope-intercept form. But we do have a form of a line, just like our slope-intercept form and just like our point-slope form, that lets us solve for these intercepts much easier. And we call that form standard form. And so, once again, this is our third form of a line. We've talked about our slope-intercept form, which was our y equals mx plus b, slope-intercept. Earlier this week, we talked about our point-slope form, which was our y minus y1 equals mx minus x1. That was our point-intercept. So this is our third and final form of a line. This is called our standard form. So standard form is ax plus b equals c. Now one thing to know is that a, b, and c in this form, these are all going to be numbers. So for example, it might look like 3x plus 7y equaling 2. That's an example of a standard form. I'm going to have a, b, and c. Those are all going to be numbers. X and y, just like in our other problems, will always be those variables. Another thing to note that a and b will never both be 0 at the same time. They can't both be equal to 0 at the same time. They can't. One can be equal to 0, but they just can't be equal to 0 at the same time. Otherwise, it would be 0 plus 0 equals a number, and that's not possible, because 0 doesn't equal 2. That's not math. So, with our standard form, the main reason we have this is because it's very helpful with finding those y-intercepts. It's very helpful with solving for those y-intercepts. And so, it is kind of complicated having to remember what's my slope-intercept, what's my point-slope, what's my standard form, and keep them straight. but they do all come in useful situations. Specifically, standard form comes in useful when we're looking for y-intercept. So let's, or x-intercept or y-intercept. So let's see an example of how to solve that. So for this first problem, I have 3x plus 4y equals 24. If I want to solve this problem, I need to plug, once again, we have to think back to an intercept. I need to figure out, I need to think my intercept occurs when one of my values equals 0. My y-intercept occurs when my x equals 0. My x-intercept equals, or occurs when my y-intercept equals 0. So I need to plug 0 in for one of these values, 0 in for one of my variables, and then solve for my other variable, and that will give me one of my coordinates for that intercept. So if I want to solve for my x-intercept, I need to plug 0 in for y. So I'm going to replace my y with 0 and see what I end up with. So I get 3x plus 4 times y equals 24. Now 4 times y, that's going to cancel out. That's just going to be 0. So this is going to actually be 3x equals 24. From here, I just have to divide by 3, and I get x equaling 8. So once again, x equals 8, that's the value of the coordinate, but my x-intercept, when I think of the point, the coordinate point, it's going to be 8, and then my y I plug in 0 for y. So that's my x-intercept. I can do this exact same thing to solve for my y. When solving for your y-intercept, we plug 0 in for our y. So that means, or 0 in for x. So that means 3 times 0 plus 4y equals 24. So 3 and 0 cancel out. That leaves me with 4y equals 24. Divide by 4. Divide by 4. I get y equaling 6. So y equals 6. So when I think about what my y-intercept is, I know it occurred when my x was equal to 0 and my y was 6. So whenever, if you're looking for your x-intercept, your y-intercept, or your x-intercept, your y is always going to be equal to 0. Your y-intercept, your x is always going to be equal to 0. You're always going to have 1, 0 in either of those intercepts. It's always going to be the opposite value. So y-intercept, your x is 0. Your x-intercept, your y is 0. That's always something important to remember. Now if we look about how we solve this, when we plug 0 in for our x and y to solve for those numbers just cancel out. They disappeared right away. So in a sense, I could pretend, when solving for this, I could just cover up that 4y and look to see what I have. Oh, I have 3x equals 24. That's what I wrote down here. Or I could pretend, when solving for my y-intercept, that I could just cover up that x, because I knew it was going to cancel out. Oh, 4y equals 24. That's what I put down here. And so we can use this covering up method where you can basically just put your hand over the value to be able to solve, or to be able to cover it up. And that can help us visualize what those values are going to cancel out and help us solve these problems really quickly. For example, if I put my hand over this 5x, I see I have negative 6y equals 60. And I can solve this. Divide by negative 6. Divide by negative 6. 60 divided by negative 6 gives me negative 10, so y equals negative 10. I know that coordinate is going to be 0, negative 10. And I was able to solve for my y-intercept very quickly. I can do the same thing yet again. I have 5x minus 6y equals 60. If I want to solve for my x-intercept, I'm just going to cover up that 6y. I get 5x equals 60. From here, just like before, divide by 5, divide by 5, x equals 12. So we can solve for these x and y intercepts super quickly just by covering up the variable that we don't need, the variable that we know is going to cancel out. One thing to take notice of, when I covered up my x, I still left that value in front of my y. That sign in front needs to stay there. I'm not going to cover that up as well. So that's negative 6 needs to stay negative. Over here, it stayed positive. So whatever value, whenever you plug in 0, you need to make sure you cancel out that value, but you need to make sure that sign stays. So take a moment, see if you can solve these next two, just like we did on those last two, and see if you can figure out what the x and the y-intercept is for both of these problems. Alright, so if we see these problems, we were able to cover up that y, and we had negative 4x equals negative 20 divided by negative 4 divided by negative 4. We got x equals 5, 5, 0. If we cover up negative 4 on this one, we see we just have y equals 20, and so we get 0 equals negative 20, or 0 negative 20 for your coordinate. So that one was really easy. Solving that second for solving the y-intercept, give it to you right away. Cover up your 2y, we get 7x equals negative 28. Divide by 7, you get x equals negative 4, negative 4, 0. Cover up your 7x to solve for your y, you get 2y equals negative 28 divided by 2, divide by 2, y equals negative 14, 0, negative 14. So just use that covering up method, cancel out one of those pieces of information, solve for your other variable, you have your two intercepts. So we talked about how to find intercepts with standard form. Now we want to talk about how to graph using standard form. Now in order to graph a line, the only things we need to know is either a point and a slope or 2 points. You can draw any line between 2 points. You can always draw a line between 2 points. So if we're able to find 2 points, we can draw a line and we can graph this form. The easiest points to find in standard form, obviously, just like we saw before, are those x and y intercepts. So if I can find my x and y intercepts, plot them on my graph, I can graph my line pretty easily. So I'm just going to use that cover up method. Cover up my negative 2y, and that leaves me with x equaling negative 2. My coordinate then is going to be negative 2, 0. Negative 2, 0 is my x-intercept right there. Do the same thing. Cover up that x. That gives me negative 2y equals negative 2. I can divide by negative 2. So negative 2 divided by negative 2 equals 1. So y equals 1. That gives me 0, 1 as my other coordinate. My x or my y-intercept. So I have these 2 points plotted. I can easily graph a line in between them. That's a pretty short line. That's not very expansive across my graph. But if I look, I can find the rise and the run. My run was 2. My rise was 1, so I can continue to use that for the rest of it. Over 2, up 1, over 2, up 1, over 2, up 1. And I can use that to find all the rest of my parts of my line, so I can have a full line across my grid. So these are very simple to graph. All we have to do, find that x-intercept, find that y-intercept, plot them on your paper, connect your points, and you have it. And you can use that y rise over run to help you find those other values rather than just those 2 points. So take a moment, see if you can try this next one. 2x plus 5y equals 20. What is your x-intercept? What is your y-intercept? Plot them, find your points, and use that rise over run to find the rest of the values that you need. Alright, so you should have been able to find your x and your y-intercepts. 2x equals 20 if you cover up that y. Divide by 2, you get x equals 10, 10, 0. Plot that point. 5y equals 20 if you cover up the 2. Divide by 5, divide by 5, y equals 4, 0, 4, plot that point. You can draw your line between them, and we get this sort of quarter of our graph line. Now, if we want to plot the rest of our points, we can use that rise and run like we did in that last plot. But our rise and run on this problem is pretty long. We see our run is 10, and our rise is negative 4. So we would have to go left 10, up 4, to be able to plot our other point, which is going to be way up here. Another thing you can do is think of that rise or run as a fraction, or that slope once again. We can reduce this. Negative 4 over 10, they're both divisible at 2. So negative 4 divided by 2 gives me negative 2. 10 divided by 2 gives me 5. So I can reduce my fraction to negative 2 over 5, which then I can go over 5 up 2, rather than having to do that full total distance of that 10. So those are other ways to plot your other points on the graph, rather than having to use that full slope between that x and that y, especially if those intercepts are pretty far apart, like they were in this case. It's easier when they're much closer together, but when they're far apart, it can be hard to use that full slope again. So you can try to reduce that slope. We're going to talk about one final thing. So we want to talk about what if A is 0, or what if B was 0? What would that look like for your line? How is that going to change your line? Not x or y being 0, but having that full value of A being 0, full value of B being 0. So for example, I put 2 examples on here. We have 0x plus 3y equals 12, or 4x plus 0y equals 12. So that whole A is 0 in this problem. So it doesn't matter, any value you plug in for x is always going to be 0. So 1 times 0 is 0, 3 times 0 is 0, a billion times 0 is 0. No matter what, this is never going to change. This is always going to be 0. So really, I could cut that entire thing out of my equation, and it's not going to change anything at all. I could really just write 3y equals 12. And this is a nice equation and all, but we can simplify this for y. If we try to simplify this, we get y equals 4. So y equals 4, I just simplify this whole 0x plus 3y equals 12 into y equals 4. Now I think, if I'm trying to graph this, when does y equal 4 on my graph? It probably equals 4 at that intercept, but if x is 1 or 2, so y still equal 4? If x is negative 4, y is still going to be 4. If x is negative 8, y is still going to be 4. If x is 20,000, y is still 4. It doesn't matter. Y is always equal to 4. So if I graph this line, it doesn't matter what my x value is, I'm just going to have a straight line at y equals 4. So I got a horizontal line for y equals 4. Let's see what happens if I get a 4x plus 0y equals 12. What type of line would that be? So once again, having 0 in for b, that's going to cancel that entire part out of my equation. So really, I just have 4x equals 12, which I can then simplify. It gives me x equals 3. Now, this is saying at any value, x is going to be 3. At any value of y, x is 3. When y is 8, x is still 3. When y is negative 8, x is still 3. Y is 64,000, x is 3. So that gives me a vertical line at all those values of 3. So this is interesting. When I have y equals, I have a horizontal line. When I have x equals, I have a vertical line. Now if we look, these are different from the lines we've had before, because all the lines we've had before have had a slope. But if I look, my slope of my horizontal line, that is a 0 slope. It's flat. It's not changing, it's not increasing, not decreasing. It's just staying 0, staying constant. If I look at my vertical line, it's impossible to count the slope because I'm not running. I don't have any run. It's like dividing by 0. So this is what we call undefined slope. You can't figure out what that slope is. It's just vertical. And so we have a special little mnemonic device to help us remember when we have horizontal lines and when we have vertical lines. And we call this Hoybux. So what Hoybux means is when if you can have a horizontal line, oh, that's not what I want. So we can have a horizontal line, that has a 0 slope when you have y equals. So y equals 4 gives the horizontal line with a 0 slope. You get a vertical line, or what is going on? You have a vertical line with an undefined slope, and that was when x equals. So Hoybux is a way to help us remember if we have x equals, we have a vertical line, if we have y equals, we have a horizontal, to help us determine how to graph these lines. So we're going to continue to practice this tomorrow and continue to work with that standard form like we did with point slope.